In today's video, I'm showing you how to use Grasshopper for 3D printing. So notice here that we have this entire script that shows you a very simple exercise on how to use this and how to create this container. Then at the end, I show you how to bake it and also get it prepped for 3D printing. So I have that here. I'll be going over all of those steps in detail. So if you have any questions or anything, let me know in the comments below. I'll also have this available on my website for a limited time, so you can play around with it and see if this kind of workflow is useful for you. So with that being said, thank you very much for joining today's video, and let me show you what this is all about. All right, the first thing we'll bring in is going to be a rectangle. Now here, there are different ways to create a rectangle, but I like to use this one because it gives us a plain input and X and Y size. So we can use a slider. I'll type in 256 and that gives me a slider of 256 and I can use that for the bed size. Now we're going to be creating the container, but what I'll do is we have this just as a reference and we're going to copy this and create a slider for the size. So 50 by 50 rectangle. And that's how big the container is going to be. So notice that what's useful about this is that we can always change the initial sizes. And so what this does is allow it to be used over and over again. Let's say you want a container that's 100 by 50. All we need to do is change the slider here. So now with this, we're going to extrude it up. But first, we need to create a wall size. So we'll go to offset curve. Notice that it's offsetting to the outside, and I actually like to do this in top view. It's offsetting to the outside. So we need to create a slider that has a negative number. So I'll just go here and let's say the wall is going to be 2.5 millimeters. It's going to the outside. So this negative component turns this 2.5 into negative 2.5. And notice that now we have this wall size. Next, we're going to turn this into a surface between those two. So there are two different ways we can do this. We can do this using boundary surface between this and this. Notice that we create two overlapping surfaces. So we need to flatten the input. Or the other way is we can do region difference. We have the outside region. We have this inside region. And then we can also use a boundary surface between those two. So these are two ways that you can do the same thing. I just think it's a little bit cleaner using region difference. Now let's create the height. So notice that all we're doing is taking the same steps that we would do inside of Rhino, but we're doing it using components, inputs, and outputs. So here we have this surface we're going to extrude, but we now need to give it a direction. Typically when you 3D model it, you just kind of go up, but here we need to use a Z vector and the direction is going to be up in the Z direction and then use a slider for the height. So let's use 50.00. Now the slider, depending on how many decimal points you use, that's going to be kind of the precision for this. So now we have the ability to first change the size. Notice that the spacing remains the same. We can also change the wall depth. So let's leave this at 2. And then here we have the height. Now we need to create the base portion of this. So let's go back. We can hide all of this. Turn this surface or this rectangle into a surface. And then extrude it up in the Z direction. So this one is the wall, and that's too much. So we'll copy this and then lower the limit of the slider. So we'll just say like 10 might be the max for the base. And now we can use this as the input. So notice that it extrudes the bottom by 10. And now let's bring back the walls and this bottom part. And now we can use a solid union to bring those two together. Notice that we have 2, so we need to flatten the input and then hide this. And notice that now we have a clean form that we can bake here, and we can analyze it within Rhino and see that now we have a perfect box that has been put together using Boolean union. Now, let's create the lid. Now, in this tutorial, I'm only going to show you one iteration on how to create an outer lid. If you guys want, I can show you other forms of creating lids on an object. So for now, let's keep this organized. Let's hide the wire on this one. And now let's create the lid. So what do we need? We need this rectangle up at the top here. So we've already moved and extruded this up. Let's move it using a move component, using this unit Z vector as the extrusion because we want it to move up that same height. Now we can use this rectangle as the input. And since some of the wires are all over the place, I do tend to hide them. And now we can get started with the lid. So we need to create the tolerance because when we close this, if we create the lid too close, then it won't close. So let's first offset curve. And the tolerance is going to be small. So I'll just do 0.35. And now we're going to offset it for the lid size. So basically offsetting once and then offsetting again. I'll just use this one, bring it over, and then it's negative, so actually it needs to be positive because it needs to offset to the outside. And now we can call this tolerance. And this is going to be lid wall. Then this is going to be base height. This is container height. Also, in the previous videos that I posted in this channel, I haven't really done a tutorial. So this is one of the first tutorials kind of showing 3D printing. And I just want to make sure that things are organized. So that's what I'm doing here is X and Y size. And this is going to be container wall. Okay, now again, between these two, we're going to be creating a boundary surface. So let's just copy this because we had already done it. Now, it'd just be doing the same thing. Region difference, taking the outside one and subtracting the inside region and using a boundary surface between those. Now, this is going to be the lid depth. So this is like how far you want it to like wrap around the top. So here we'll do extrude, but down. So let's just copy this. And then extrude it down using negative. And then extrude this down. And we just need to preview it because I can tell it's not being previewed because it's dark gray. So we'll preview it. And now here we have the cap height. Next is taking the outside curve and turning it into a surface using boundary surface and extruding it up. So extrude will basically copy this, and then instead of down, it's going to be up. And then this will be the top part. So this surface that we created with that offset becomes the top, and those two that we offset here become the cap with the lip here. So now the same thing that we did before is use Boolean union between those two. But here in Grasshopper it's called solid union. We'll flatten the input and then take a look at the result. So this is going to be the cap height, cap lip height, okay. And so let me show you here using this geometry component. We'll plug it into this one so we know that this is going to be the container. I'll hide all of this and then do the same thing here. This one's going to be the lid. Now here's the one thing. Notice that these are called creases where those two were joined together. I'll use merge all coplanar faces or merge all faces, and that should clean up the form. Notice that we don't have that anymore. And we have the container and the lid. So now using this, I'm going to take this container, use a custom preview and a color swatch, just so we can add a bit of material to the script and we can see it. Make this red like this, and then hide the wire display and do the same thing to this one. But I like to change it a tiny bit. One's going to be darker than the other. So what I've shown you here is basically how to create a parametric script for 3D printing. Now I want to bake this because I want to show you that if we take this here, we go to a clipping plane, make sure that it's a vertical cut, and now we can take a look at the script here. So notice that we have the container size, we have the wall, the height, then we have the tolerance, the cap lip, and then the cap depth here. What's great about this is we can change the size of it depending on exactly what we want. We can change the height of it. Oh, the base height, that's wrong. That's down here. We can't really see it. And then the container height. Let's see what happens if we take this rectangle. So we're going to, now that we've kind of created the overall form, is with all the steps laid out within a script, you can then add modifications that can help you further adjust your script. So we know that everything is based off of this rectangle. So what if we took that rectangle, I double clicked on the output, and that creates a relay. Now all of the information goes out of this relay to the different components. And then here we use a fillet. There are different fillets that we can use. There's this one, and this one. We'll just use this one for today. And then the radius, we'll just say 2.5. Notice that now not only does it create the container as a rectangle, but it can also use a fillet modifier to update this. And if we go back to the color and change some of the opacity so we can kind of see through, change this to maybe 150. You can kind of look through into the inside, and then let's bake these one more time just so I can show you how this works. Clipping plane, vertical. And yep, it works. So I'm going to do a small test print. Let's say you just use this. And what I do is, let's say we have the script here, bake the information, then bring it over here, take this, flip it over. And then this gets printed flat on the bed plate, and this one also. So now to put them together, I just move them right next to each other and then move it by 1 millimeter. Then turn these into a mesh using my previous options. That didn't work. All right, let's do that again. Mesh. Let's erase all of the options here. Do that again. Mesh. And then here we'll just go to detailed. .01 or 0.1 on this one. It's just a quality thing. So, okay. Now notice that I've created this high quality mesh, and all I need to do is export this as an STL to see if it's going to print. So let's do that. Let's take this file, export selected, and I'll move this to my desktop and save it as an STL. That's the most important thing. And call this box test. So here I am in Elegoo Slicer. I'm going to set this box in here. Notice that it's the same size, and having that image as a reference or this picture as a reference, it really helps visualize how big it's going to be. And then in here, let's see if I slice this plate. This one would take about 20 minutes to print. And notice that since we have 2 millimeters for the wall, then we have the corresponding amount of wall segments. So I'll be test printing this, and I'll let you know what I think about it and how it went. And let's see, for now, let's conclude by going over all of the steps here, showing you how parametric design is actually super useful for 3D printing. And the reason why is because you can change the sizes of this, but still maintain, let's say, the container wall to be consistent. Same with all of these. So let's take this, move it out of the way, and let's go back and just review this to show you. So this is going to be the bed size. This is more than anything for reference. The X and Y size for the container wall, which is based off of the original rectangle offset and creating the height. Then we have the base portion of it, which is this, that gets put together with the walls to create the container. Then we have the tolerance, the lid wall, the cap height, so the overall cap height, and then the lip height, which is this one. And that depends, because if you don't have it long enough, then the container will tend to open up by itself. And also playing around with the tolerances will help you understand how different shapes and different containers may need different tolerances depending on the geometry. That's one thing to keep in mind. And then at the end, we have both the lid and the base that we can bake and use. So hopefully that covered a little bit of what this is all about. I will be posting more video tutorials on how to use this tool for 3D printing. I feel like it's one of the best tools for it. But it's also useful because you can use the script over and over again. So thank you very much for being here. Hopefully you enjoyed this tutorial. It's a little bit different than the videos that I've done in the past. If you have any questions, let me know in the comments below. The script will be available for free for a limited time. So go ahead and check that out on my website. I appreciate you coming by today, and I hope to see you in the next one.